Technical specifications for SDH Telecommunication System. System availability. Overall availability. The telecommunication system shall be designed to meet an overall availability criterion of 99.99%. Critical components. All active devices that can form single points of failure along the communication network shall be avoided, where reasonably possible, for critical subsystem components. Design life. Equipment and components. The fiber optic telecommunication equipment and components will be suitable for continuous design duty operation for a period not less than 10 years without the need for a system revamp due to technological obsolescence. Telecommunication system. Primary function. The primary function of the fiber optic telecommunication system is to facilitate the operation of the SCADA system to allow safe and efficient operation of the pipeline and the facilities with the minimum of manned intervention. Operation. The design of the telecom system shall be based on a 24-hour per day, 365 days a year operation from all manned and unmanned locations of the pipeline. Target availability. The target availability for the entire telecom system shall be 99.99%. This availability shall be substantiated by telecom vendor availability calculations. Fiber optic telecommunication network philosophy. Backbone design. The fiber optic telecommunication network backbone design shall be based on distances to be covered across the pipeline, the type and criticality of systems to be interfaced with, as well as bandwidth, availability, and reliability requirements. The fiber optic telecommunication networks shall be based on a sequential network topology with redundant direct transmission paths. Backbone cable. A single 24-core fiber optic cable of G655 cable running through the entire pipeline corridor, forming the fiber optic backbone of the entire fiber optic communication system. SDH system. An SDH-based communication system which will carry all SCADA ICS LANs, ISS systems LAN, as well as voice, video, radio, office LAN systems data using dedicated fibers on the FO backbone. The SDH network shall interface all systems requiring communication between all manned and unmanned stations. System spare capacity and spares. Hardware spare capacity. 20% spare capacity on interface I/O cards, wired and terminated, ready to configure and use. 15% spares supplied for cards, terminations, and physical slots available for use, but not installed. 25% expansion space capacity provided in cabinets racks for cards, terminations, and termination space in the cabinets, but no hardware supplied. Systems, servers, workstations spare capacity. Maximum of 30% system memory RAM utilization, under maximum load, for all servers' workstations. Hardware upgrade space slots to install a further 50% memory which the system can use. 50% spare storage capacity memory, hard disks, under operation, for all servers' workstations after installations of all application system software. 50% additional storage memory, upgradable space available for future hot plug upgrades. 100% spare software license capacity available for all application system software installed. Additions of workstations consoles ready to configure and use without the need for additional licenses. 50% spare historization storage space for all servers having historization feature built into application/system software, ready to be configured and used. Additional spares, other spares, wherever required, shall be recommended for the fiber optic telecommunication systems vendor. Standardization of equipment, equipment standardization. All the equipment and components of the fiber optic telecommunication systems shall be standardized wherever possible to ensure commonality of spares throughout the pipeline sites. Minimized training required on the same purpose equipment. Economies of scale when purchasing replacement components and maintaining spares across the system. Greater economies for maintenance and servicing support for installed equipment. Uniform system. The systems described shall have a uniform set of licenses/software, hardware/firmware used for the entire system, ensuring a uniform system upgrade in the future. Best practices. The selection of hardware components shall follow the best current industry practices in configuration, monitoring, performance, networking, distribution, and considering all aspects of operation and maintenance. Technical specifications for SDH telecommunication system. SDH system, SDH architecture, overall configuration. The SDH network shall be designed with SDH as a hub of communications between all control centers, valve stations, and terminal stations. System design. The SDH network design shall be based on STM16 2.488-bit-based fiber optic communication system, tying all manned and unmanned facilities between control centers. The primary SDH network will terminate at the main control center. The SDH design basis. Network design. Each SDH network shall comprise a 4x4 fiber-protected self-healing MSSP ring system operating at STM16 2.488 Gbps. This ensures that the network can carry twice the traffic of a 2-fiber ring and provides protection against single failures. Fiber optic backbone cable. The main fiber optic backbone cable shall be a 24-core standard ITU-T G655 non-zero dispersion suited for long-haul applications. Redundant paths. Redundant fiber links should be used to ensure high availability and reliability. The SDH subnetwork connection protocol. Subnetwork protection. The subnetwork connection protection SNP method employed is critical to establish maximum network availability. Each transmitting signal node shall be permanently connected in both main and protected traffic directions. Automatic and NMS level switching. The switching decision of transmission paths shall be possible both automatically and at the NMS level. The SDH backup strategy. Backup strategy. The backup strategy for the SDH transmission system shall involve auto-fallback switching mechanisms within the SDH backbone. In the event of a failure, selected services will switch to an external backup link. External backup link. This backup link should be a secure, fault-tolerant, and high-availability alternate path for point-to-point connectivity. The SDH hardware, SDH STM16 terminal. The SDH STM16 terminal shall comprise optical line terminal equipments, OLTs, add-drop multiplexers, ADMs, and other necessary hardware components. OLT specifications. Minimum specifications for OLTs include compliance with ITU-T G9957, launch power, receiver sensitivity, protection requirements, and modular design for maintainability. Cross-connection capability. Cross-connect capabilities. The STM16 multiplexer shall be able to cross-connect various data streams, including VC4, VC3, VC12, Gigabit Ethernet, and 10100 Mbps Ethernet in multiple configurations. Technologies utilized. The cross-connect capability shall utilize GFP, VCA, and LCAS technologies to maximize bandwidth usage and ensure undisrupted traffic. SDH tributaries. Components. The SDH tributaries equipment shall include STM4, STM1, Gigabit Ethernet, 10100 Mbps Ethernet, and E1 tributaries. Minimum specifications. Each type of tributary shall meet specific standards and performance criteria, including bit rates, coding formats, jitter tolerance, and EMC ESD compliance. EOW service channels. Engineer order wire, EOW. EOW shall be provided for each OLT to enable communications between nodes during maintenance and commissioning periods. It should be directly modulated onto the aggregate optical line signal. Primary multiplexer. Redundant configuration. The primary multiplexer shall be in a redundant configuration capable of demultiplexing a 2.048 Mbps input into individual channels. Protection and interface requirements. The primary multiplexer shall meet specific protection and interface requirements, including 1+1 protection for common control and power supply, and be capable of interfacing with synchronous and plesiochronous networks. Time synchronization. GPS-based synchronization. GPS-based system synchronization, primary reference clocks, PRC, and timing distribution units shall be provided and integrated into the SDH system. Clock input-output should comply with G.703, and multiplexer OLTs must be able to receive time synchronization signals from external sources and pass timing to outgoing lines and tributaries. Alarms and monitoring. Alarm systems. All telecom equipment shall contain proprietary alarm systems with indications for critical, major, and minor alarms. Alarm notification shall be indicated locally and remotely. Remote configuration. The NMS should be able to download software changes and change configurations of individual card options or connections. Communication network statistics. Statistics collection. The NMS shall collect sufficient statistics to evaluate equipment performance, interface cards, and connecting backbone circuits. Reports should be collectible by individual circuit, and pre-programmable self-diagnostics should be part of the statistical collection effort. Have accessibility. Access levels. The SDH equipment shall allow various levels of access to multiplexers, with the highest level allowing control and testing, and lower levels confined to monitoring and collecting statistics. Protection features. 1+1 protection. Equipment shall have 1+1 protection on the line aggregates and N+1 protection capability for common control cards. Key alarm indications shall be externally hardwired for connection to SCADA RTU for alarm display. Bridging features. Multi-point data circuits. The digital and analog bridging equipment shall have the capability to bridge circuits to establish multi-point data circuits or voice party lines. Optical amplifiers. Performance assurance. Where link budget calculations show potential performance issues, additional optical amplifiers shall be installed at terminal locations or intermediate repeaters. Equipment layout. Standard cabinets. All telecom equipment shall be mounted in standard communication cabinets with louvers fans for ventilation. Cabinets should be equipped with slide rails/trays and swing door frames for easy access. Patch panels. All copper and fiber cables shall be routed to suitable patch panels for access, and all panels should be intelligent type with monitoring systems integrated with the NMS. Grounding compliance. Grounding of all cabinets, racks, and chassis of enclosed components shall comply with industry standards. Network management systems. General requirements. Integrated NMS. An integrated network management system, NMS, for monitoring the operational status of the transmission systems and miscellaneous equipment shall be provided. System monitoring. Dedicated network management systems are required for the SDH network and all interfacing services, and a fiber cable monitoring system, FCMS. The installed NMS system at all locations shall maintain real-time status of the fiber optic network and all connected network elements. Control center integration. The NMS system shall be tied into RTUs through volt-free contacts for monitoring SDH status and alarms, allowing overall system status to be monitored by the process control operator. Operator interface. Graphical representation. The NMS shall provide an overview of the telecommunication system with a graphical representation of its status, including fault reporting, network utilization, and other key metrics. Alarm notification. The system shall rapidly display any relevant network problems alarms to notify the operator of the problem type and location, including critical, major, and minor alarms. Control capabilities. The operator interface shall allow for automatic reconfiguration and restoration in response to network conditions and offer detailed monitoring of network devices and service devices. Management interface. Reporting and logging. The NMS shall include a logging facility that records all alarms and other events, along with a reporting facility that provides information about current and historical network status, such as alarms and outages. Security. The system shall be protected with a security system using usernames and passwords, offering varying levels of access for operators, system managers, technicians, and view-only users. Automatic device detection. The NMS shall automatically detect and display new devices on the telecommunication system and indicate disconnected devices as an alarm. Maintenance interface. Self-diagnostic capabilities. The NMS shall have self-diagnostic capabilities, providing self-monitoring and verification of its functionality. Remote configuration. Maintenance laptops shall be provided at key control centers, capable of accessing the NMS system and viewing the entire SDH network from any node. Configuration control. The NMS shall allow for remote configuration of individual card options or connections, including switching from primary to secondary lines and loopbacks for troubleshooting. Server interface, interface development. The vendor shall supply a functional design specification document detailing the development and refinement of the NMS interfaces, including standards for screen layout, colors, fonts, navigation tools, and alarm reporting structure. Server redundancy. The NMS system installed at the primary control center shall operate as the master system, with secondary control centers assuming control in case of failure or loss of communication with the master NMS. NMS maintenance terminals, laptop computers, maintenance laptops at each control center shall be capable of accessing the NMS and viewing the SDH network. These laptops shall auto-synchronize with the NMS servers for real-time network status and database updates. System restart and data retention, automatic reconfiguration. The NMS shall ensure automatic reconfiguration and restoration following network failures or disruptions. Data retention. The system shall have built-in storage for performance snapshots to assist in troubleshooting, even if the main connection is lost for a period. Diagnostics and testing. The NMS shall include pre-programmable self-diagnostics as part of its statistical collection effort. The NMS shall collect and evaluate performance statistics for equipment, interface cards, and backbone circuits, providing detailed reports for analysis. By adhering to these specifications, the network management system ensures comprehensive monitoring, control, and maintenance of the SDH telecommunication system, contributing to the reliable operation of the entire pipeline communication network. Quality assurance. General requirements. Quality assurance program. A comprehensive quality assurance program shall be established to ensure that all equipment and systems meet the specified requirements and industry standards. Compliance. All components and systems must comply with international quality management standards such as ISO 9001. Documentation. Detailed documentation of all quality assurance processes, procedures, and results shall be maintained and made available for review. Vendor responsibilities. Vendor quality control. Vendors supplying equipment and systems must implement their own quality control procedures to ensure compliance with the specifications. Certification. Vendors must provide certification and documentation demonstrating compliance with the specified quality standards. Inspection and testing. All equipment must undergo thorough inspection and testing to verify compliance with the specified quality and performance requirements before delivery. Inspection and testing. General inspection and testing guidelines. Inspection plan. An inspection and testing plan shall be developed, outlining the specific tests to be performed, the criteria for acceptance, and the schedule for testing. Test methods. All testing methods shall comply with relevant international standards and industry best practices. Documentation. Detailed records of all inspection and testing activities shall be maintained, including test results, observations, and any corrective actions taken. Site acceptance test. Scope. The SAT shall verify that all installed equipment and systems meet the specified performance and operational requirements. Procedure. The SAT procedure shall include functional testing of all components, system integration testing, and verification of proper installation and configuration. Criteria. Acceptance criteria for the SAT shall be clearly defined, and any deviations from these criteria must be documented and addressed. Performance acceptance test. Objective. The PAT aims to confirm that the system performs as specified under normal operating conditions. Testing conditions. The PAT shall be conducted under conditions that simulate actual operational environments as closely as possible. Evaluation. The performance of the system shall be evaluated against the specified performance parameters, and any deficiencies shall be corrected. Documentation. Comprehensive test reports shall be prepared for all inspection and testing activities, detailing the procedures followed, results obtained, and any issues encountered. As-built documentation. Complete as-built documentation, including drawings, schematics, and specifications, shall be provided to reflect the final installed state of the system. Operation and maintenance manuals for all equipment and systems shall be provided, including detailed instructions for troubleshooting and repair. Spare parts and special tools. Spare parts inventory. A recommended inventory of spare parts for all critical components shall be provided to ensure quick replacement and minimal downtime. Special tools. Any special tools required for the installation, maintenance, or repair of the equipment shall be identified and provided as part of the project. Training program. A comprehensive training program shall be developed and implemented to ensure that all personnel are adequately trained in the operation and maintenance of the system. Training materials. Detailed training materials, including manuals, presentations, and practical exercises, shall be provided. Hands-on training. Practical hands-on training sessions shall be conducted to ensure that personnel are proficient in using and maintaining the equipment. By adhering to these specifications for quality assurance, inspection, and testing, the integrity and reliability of the SDH telecommunication system can be ensured, contributing to the overall success and safety of the pipeline project.